I'm, as many people have said, I'm very honored to be here. I'm going to talk a little bit about concrete ESP as much as anything else, and I don't think we'll be bending any spoons as we work our way through this. But I did want to start off, as many people have, of how they were introduced to Ken or how they got an opportunity to meet Ken. I was speaking at an ACBM teaching workshop in 1997. We were in a glorious garden on a Sunday afternoon. All right, it was about 70 degrees. It was beautiful. I happened to be the second speaker at the event. I, of course, was very nervous because it was the second talk I had ever given. But I was like, I got my 13 transparencies in hand. What could possibly go wrong on the way to this? All right, giving a very stirring lecture on coupled laboratory experiences about something. Well, immediately the first speaker started, and I was disappointed I didn't have seatbelt on my chair because it started in a hurry and it went for the next 45 minutes. At one point there was a Hershey bar that flew by. I remember a box of cereal. There were koosh balls going. Everything was going on. I was either stunned by how wonderful the lecture was, or I was hit with a block of Velveeta cheese. But I was so immersed, I was so glad that the moderator said, we should take 5 minutes to regroup, all right, and then move on to the next talk, all right? But I kept asking myself, because this was the second talk I had ever given, is this a typical presentation? And I learned very quickly, Ken Hover, typical, they are not in the same sentence, all right? It is that exceptional that we really talk about. Now, I wanted to talk a little bit about greatest hits, all right? So I looked up different people's greatest hits. A lot of people think this may be a little group called the Beatles. This was actually at an ACI convention, all right, where people were really clamoring to get Ken's work on plastic shrinkage and neutron radiography. So we're going to talk a little bit later about how we're essentially starting to utilize these. But I want to also just mention there's a lot of work that Ken has done, as many people have talked about here, in the educational space. And one of the things that I always find that's very interesting, we've spent a lot of time at different ACBM teaching workshops talking about this, is his ability to take what you think you know and to describe it in several different ways or present it in a different graph, where all of a sudden you start thinking about this in a different direction. So, you know, several of these papers that are out there in Concrete International are required reading, whether it's making sense out of concrete, whether it's the graphical approach to mixture proportioning. These are all things that we use very, very currently. Now, when I talk about ESP, it's really bringing educators, suppliers, and practitioners together to start talking about the overall performance of what we're doing in these systems. And I just want to mention, there's lots of papers that we could pick. I picked 2 of the papers out of there. The first one, there were 4 conclusions, and I just want to read 3 of them to you. One is, if you want to reduce cracking, reduce your paste content. Right? The second one is, the construction operations are also important. All right? It's not just a materials thing. We have to actually be able to build it. We have to understand what's being done. And the third one is, the rate of evaporation isn't enough. We need to know something more about these systems. And I think as we start to look at this, all right, we're going to actually start going through this and say there's a lot of truth to what's being said here, and all of this is really key as we start to move forward into low carbon concrete. The other paper I'll point out is a paper on neutron radiography, and this was building on a series of some very influential work that was coming out of Cornell. They were using neutron radiography to study cracks and doing quite some interesting work. I will say I think it's the first paper on neutron radiography and concrete that are both in the same title. And we actually use both of these techniques to look at these together. But as I mentioned, I think we have a challenge as we move forward to really take a lot of the fundamental aspects that Ken has talked about and say, how do we start adapting these to our sustainability goals? You know, when we look at plots like this that are put out by GCCA and we say over the next 50 years, we're going to use less cement, which was a conclusion from that nice paper from 1992, right? We're going to use more SCMs. We're going to use things other than clinker in these mixtures. We have to really start thinking about how that impacts some of the fundamental things that we know, right? How does that impact things like the fineness, and the bleed. Now, I'm not going to try to go through the samurai sword, the Velveeta cheese, and the salsa, because I've always fallen down on how that relates to surface area, all right? But surface area is incredibly important, all right? And we know that the surface area is important, and what I found really interesting in reading this paper from the 1970s is they were unconvinced that we really needed this sophisticated Blaine analysis, but they knew that they needed to know more about surface area. And this is a key thing that we keep coming back to in all of our mixed design, all of our fresh property aspects. The bleed rate, right? Not everything, but it's important, and it changes when we change these constituents. The surface chemistry also changes. So to pull all this together, if we take all of those features and bring them together, the red dot is plain concrete. The green and the blue dot are when we start to get more quote-unquote sustainable concretes. And what we start to notice is the cracks get bigger, the cracks become more frequent. So we really have to go back to some of these pioneering works on fresh concrete and plastic cracking and really make sure that we have a lot of these basics. Right? We can actually take, and this is one of the things that I think is really reflective of what Ken does, we can take technologies from completely other fields. Right? I've heard him talk about the lake in Oklahoma and the evaporation and all those good things that people were doing. Right? We can take this. This actually isn't a concrete type of plot. This is used in the freeze drying of fruit world, where they deal with drying. Right? And we talk about the fact that there is a loss of water. Then the water starts to leave the actual systems. And we really start to worry when we're in that CD range. All right? You saw that in one of Ken's papers. That's where plastic cracking really starts to occur because we've now consolidated the system as much as we can. What we've been trying to work on is using neutron radiography to see how moisture leaves these systems. All right, and it turns out that it's actually quite complicated because you have reactions going on at the same time you have the system consolidating. And a lot of people have talked about, in some of the more modern materials, this apple pie crust that forms on the top of the system. We can actually repeat some of this. Right? In this particular case, we turned off all the reactions in our cement just to see what the moisture distribution should look like. These vertical lines are the moisture distribution. It never looks like that in concrete because it's complicated, right, by the fact that hydration is also going on. And every time I look at this, I sort of am reminded of a quote that Ken gave after about a 42-minute explanation on something. He said, wow, there's wild stuff going on in there. All right, and there is wild stuff going on in there that we have to look at. But there's still a lot of work that we need to do. We need to understand things like the surface chemistry. But I think the real key to moving this forward is this approach where we bring educators and researchers, suppliers, practitioners together, because this is really the only way we can get at the heart of this and start to solve some of these problems. Now, as I go to wrap up, all right, I'm not sure how many of you have ever seen this cartoon. Has anybody ever seen this cartoon? All right, so this cartoon was very exciting for me. I thought this was the greatest thing ever on television. Right, probably says a lot about me. All right, but this is a show called Tennessee Tuxedo and His Tales. This came out of a declaration that the FCC commissioner declared that TV was a complete wasteland. He wanted educational programming. And CBS worked together with General Mills and Pillsbury to sponsor this show. All right? And the show, the whole goal was designed so that children could learn, right, where they didn't feel they were being lectured at. Right? And I'm like, now that I've read that, I'm like, wow, that was really good because I never felt lectured at while I watched this show. All right? This happens to be episode 17 where they're learning how to build a bridge. All right? And a little bit of the background on this show. Clearly, you can see we have some animals. They are at the zoo, and their goal is to get out of the zoo. That's every episode is the same thing. They want to get out of the zoo. Tennessee Tuxedo is a penguin who's desperate to leave the zoo. He's always working on some scheme. I am not going to say this is the concrete industry. You can figure your own thing out there. Right? But his dim-witted friend Chumley always suggests, Tennessee, we might need some extra help. And when they suggest they need extra help, they go see the man with all the answers, Professor Phineas J. Whoopi. All right? And Phineas J. Whoopi, as we've heard here, all right, a good professor does, he patiently explains all of the science. And as Tennessee and Chumley head off to implement this. They've usually missed one really important thing. It gets them in a lot of trouble. After they fail, they go back to the professor and he says, "But boys, I tried to warn you, you should have done this." Now what's interesting is the creator of this show said that Professor was loosely based on the Wizard of Oz. I don't think it was really the Wizard of Oz, right? I think if you look really closely, all right, you can see the man with all the answers, all right, is Ken. And Ken, on behalf of all the Chumleys out there, all right, who have been taught, retaught, and warned, all right, we do appreciate the man with all the answers. Professor Kenneth C. Hoover, you're the greatest.